for the first time, your screen will be a little emptier than this. What I see in my screen is all my previous experiments, their status, when it was submitted, how long it took, and the compute target it used, all that information over here. But for this example, we're going to go ahead and create a new AutoML run. So I'm going to go ahead and do that. So since you're doing this for the first time, what's expected is that you'll need to create a data set. So if you follow the lab, it actually shows you how you can create your data set and all that information. So this is something that I'm going to skip right now, but if you do have any questions about it, feel free to stop me. But with AutoML, from the UI, you're able to upload your data set using local files, data store, web files, or open data sets. We did provide you with a link to the data set, so you have the option to either download it onto your local computer or just provide the web file link directly. So as you can see in this example, I already have my bank marketing data set here. So I'm just going to go ahead and use it. We could also quickly just explore it so then you have an idea of what it looks like. So this is what the data set looks like. So we see age, job, a lot of different columns, but the column that we will be predicting on is here, this Y column. So as you can see, there's only two possible variables here. So it's a no or yes. So we're identifying if they get a term deposit or not. So I'm going to go ahead. And then another thing we could do is look at data statistics. So this kind of profiles your data for you. So you're able to see, like, for example, the min value, the max value for a specific column. So in this case, age has a min value of 17, but a max of 94. This just gives you a better understanding of your data before you start your machine learning experiment. So I'm going to go ahead and close this. Click on bank marketing, and I'm going to go ahead next. So if you have any questions about the data set stage, feel free to just go ahead and ask me right now, or we could go ahead and talk about it in the Q&A section of this presentation. So the next thing I'm going to do is give my experiment name. In this case, I'm going to call it bank marketing. You do have the option to either use an existing name. So when you do that, what happens is, let's just say I already previously ran an experiment with the name bank marketing. All of my AutoML runs with the name experiment bank marketing will appear in that same folder, for example, and I'll show you what that looks like when we finish this experiment. But if you wanted to start completely new, make sure none of these runs associate with the older ones, you could go ahead and create a new one, and you could just have a fresh project sort of thing. So I'm going to go ahead and create an existing one. In this case, as I mentioned earlier, the target column is a Y. I'm going to go ahead and choose my compute cluster. So this is what I'm going to be using to train my experiment on, and it's automatically going to scale to my experiment needs. Let me use another one over here. Let me use CPU cluster 2. And again, you could go ahead and create a new one and just be considerate of which one you use based on the number of nodes and all. So I'm going to go ahead with CPU cluster 2, which I created a little earlier. So the next thing I need to do is decide what is the task type. So currently, AutoML supports classification, regression, and time series forecasting. As we know in this example, it's a classification example as we are deciding whether someone gets a term deposit or not. So it's yes or no. So I'm going to go ahead and leave it selected as classification. Some additional things that we could do is we have some additional configuration settings. So I'm going to go ahead and click on that. So AutoML automatically has some default settings, but if you want to go ahead and tweak it up, this is your opportunity to do that. So one thing that you could do is choose a different primary metric to optimize on. So the default setting was accuracy, but let's just say if I want to optimize on AUC weighted, I could go ahead and click on it over here. So AutoML also has an explainability story. So if you want your models to be explained in the end, go ahead and set this to true over here by just enabling that. But if you don't have it enabled right now, you do have the option to run explainability after the AutoML run is complete. So you still have that option over there. You have the option to block some algorithms. So let's just say you only want to run it with like GBM or something. So you could go ahead and block everything else. I'm going to just leave it the way it is for now. So then you see that how AutoML actually works. AutoML also has some exit criteria. So let's just say you want this job to complete within 1 hour, not 3. You could just replace that over here. Also, maybe you might say that once my model gets an accuracy of 95%, I want to exit this experiment. So over here, you could just specify that metric threshold, and it would automatically exit once it reaches that score. We do have some validation type options for you. So these are the ones that we currently support. If you're looking for more details on how each of these work, we do have documentation. I will make sure to paste that in this chat before this meeting is over. And then we also have some additional settings like Mac concurrent iterations. Now, I do want to let you know, so these settings are, they're like, for the UI, we do have some additional settings when you're using the Python SDK, and I'll show you some of those additional settings when we get to lab number 2. So I'm going to go ahead and leave this the way it is. I'll just save it. And the next thing I want to show you is featurization settings. So I'm going to go ahead and click on View Featurization Settings. So what this does is AutoML currently has auto featurization, so automatically do it for you. But if you want to customize it, this is your opportunity to do that. So you could go ahead and include or exclude columns. You could specify the type. So for example, age might be detected as a numeric when it's auto, but we might want to say that keep it as text. So we could specify that over here. If there's any missing values, we get the option to impute it with mean, most frequent, or median. And so these are some of the feature customization options you have over here. I'm just going to leave it the way it is and just exit this from here. And then once I'm happy with all my settings, I could go ahead and click Finish. And what's happening now is AutoML is intelligently testing multiple algorithms and hyperparameters to find that optimized model for you. So this is what we see here. We can see our run detail page. So we see some properties, and these are the things that we specify. For example, the compute target. This run ID is automatically generated. We could see the run number, for example, and all that additional details. And then we have the run summary page, and this is basically all the configurations we selected from the UI. So for example, we specified that the task type is classification. We specified the primary metric to be AUC weighted. And then we could also see the run status. Currently it's preparing, so we won't really have that much information, but once it's completed, we'll be able to see more details. I'm going to just go back while this one continues to prepare. I'm going to go to Experiments tab over here and open up a run that completed a little earlier. So if I go back to this bank marketing folder, so since I use the same experiment name, I'll see all the previous bank marketing experiments in the same folder. So I'm going to go ahead and click on that. So you could see, for example, this is the one that I just launched. It's still in preparing status, but I could go ahead and open up a run that completed earlier. And for example, this one, I completed this in July 30th. So I'm just going to go ahead and open that. So right here, we see our completed AutoML run. We see the best model. In this case, the recommended algorithm is voting ensemble. It had an accuracy of 0.91502. But if that's not enough information for me, I could go ahead and click on this View All Other Metrics tab. And now I could use these additional metrics to identify if this model is good enough for me. So that's what I'm going to do over here. So once I'm done evaluating the metrics, I might want to see how the other models perform. So remember, AutoML is not only testing one model, it's testing multiple models. So here we can see within the specified time limit, so for example, 3 hours, AutoML intelligently tested all these possible options, and it provided you with the accuracy for each of them. The best model is the one that's recommended and highlighted over here, and we see that's voting ensemble. If I want to explore another model, I could totally do that. I could go ahead and click on this stack ensemble, for example. I could see its accuracy. I could see the additional metrics. And you could also go to click on this metrics tab over here. So what this does, it provides you with all these charts and stuff to further evaluate how the model performs. So for example, let me just see. So these, like we have the precision chart, the true positive rate chart. All of this information is just to make sure you can understand your models better. So that's what we're doing over here. I'm going to go back to run 1118 over here, just to go back and show you the explainability chart. So if you go back to the models tab over here, you would see that only the best model had the explainability on it, few explanations, but you do have the options to go ahead and run explainability on one of the other models if that's what you want and if you don't want to continue with the recommended model. So I'm going to go ahead and click on view explanations for the one that's already recommended. So what this should do is it's going to provide you with visualizations. So we see the global importance, summary importance, and we should also see the local importance, which I'll pull up in a bit. But over here, we can see that which features played an important role in the predictions. So for example, duration and NR employed had an important role on whether a client got a term deposit or not. So if I click on summary importance, this will help me open up the local importance chart. It will take a minute. Let me just click on. So if I click on one of these data points over here, you can see that for this one individual point, we could see the feature importance value. And again, we can see how duration negatively impacted the term deposit selection, and NR employed had a positive impact. So you could see this, and we provide explainability for both raw and engineered features. So you could go ahead and click on the charts for that. So that's basically AutoML from the UI. Now, once you're happy with your model, you could go ahead and deploy the model. So I'm gonna go ahead and click deploy over here. And it's basically a one-click deployment. You just need to provide a name, choose the compute type you want to deploy to, either Azure Kubernetes service, which is a production environment, or Azure Container Instance, which is a testing environment. And then you could go ahead and click deploy. Let me just call this bank marketing and deploy this to ACI. And you could go ahead and click deploy. And now my deployment's under, it's going on right now. Once it's complete, if I click on endpoints, I should be able to see it. So you can see this bank marketing one that I just launched. It's going to take some time to complete, but you'll see it when you're running through it end to end using the lab part one. Also, another thing is the models automatically will get registered when you deploy your model. So you can see all the registered models over here. So that's basically AutoML from the UI, and you could do that, all of this from part one. Definitely explore it using the bank marketing data set and maybe even your own data set. This example uses classification, but I definitely recommend trying forecasting or maybe regression, as some of the settings are kind of different when you do certain task types. So if you have any questions about the UI, this is a good time to ask. Any questions? And let me know if I'm going too fast. Happy to slow down. Okay, and feel free to also put it in the chat if that works better. If you'd rather ask questions in the chat, we could definitely monitor that and definitely get answers for you. So once you complete lab part one, I'll go back to the main page. So you've already run an end-to-end experiment using the AutoML UI, and you're now familiar with Azure Machine Learning Studio. So that's what we did over here. The next thing that we're going to do is jump over to lab 2. But before we do that, you'll need to create a compute instance, and I'll tell you why. So I'm going to go back to the ml.azure.com. This is what it looks like. And the first thing that you'll need to do before you get to lab part 2 is create a compute instance. And all you need to do is click on compute over here. And what compute instance does is it provides you with the compute to run your notebooks on. So as you can see, I have one running already, June 2020, but you could go ahead and create a new one. It shouldn't take that long. All you need to do is give it a name, make sure like you choose what type you want, choose the virtual machine size, again, based on your experiment needs and whatever you're running, make that decision. And then go ahead and click create, and it'll take a couple minutes to start up. And once it's ready, you could go ahead and just click leave. You could go ahead and you'll see that it says running, and that's when you're ready to run it. And you have a couple options here. You could either run it from a Jupyter Lab experience, Jupyter experience or our studio, but for AutoML, you can only use it with Jupyter Lab and in Jupyter. So just a note out there. I'm going to go ahead and click on Jupyter Lab so that you see what it looks like. But while that opens up, I'm going to also show you what it looks like from the Notebooks tab from ml.azure.com. So if I click on Notebooks, so what you'll see is a bunch of folders. So these are all the users using this notebook folder, and you can see a bunch of notebooks under each section. So for example, classification, benchmarking, all features. I should be able to see the notebook right here. And I could go ahead and run this notebook all from this notebooks tab. Now, if you prefer a Python experience using Jupyter Lab or Jupyter, you could just go ahead and launch it virtually. That's what I'm going to do for the rest of the lab. So now you can see you can run this all from here. Pretty cool. Another thing I want to show you quickly is how you can access some of our sample notebooks. So if you click on sample notebooks from this notebooks tab, you'll see samples, click on Python, and then click on this SDK version. So it's 1.110, how to use Azure ML, and then you'll see automated machine learning. And under there, you'll see all different types of notebooks, depending on your task type. So in this example, so since I already have my computer instance set up and it's running, I'm going to go ahead. So what you'll need to do is copy this link over here and go ahead and clone it from your terminal window. So I'm not going to be running all of this today on my experiment on my Jupyter Lab, but I'll show you what it looks like when you do. So once you clone this, and then for lab part 2, we're going to be using a forecasting example, just so that you get a idea of what our forecasting tool looks like. So you could go ahead and clone that. Okay, so I'm going to go ahead and open up that notebook right over here, and just briefly walk over some of the steps, and then we can have Q&A right after. So once you open up this notebook, you would be able to see it from Jupyter Lab. Keep reading. I'll just wait for that to load, but I'm going to go ahead and show you what it looks like from here. So when you're running an AutoML experiment using a notebook, there's a couple things that you'll need to do. So since you are going to be running this notebook from our machine learning workspace, all your subscription information, your workspace information is already there. All you'll need to do is make sure you call that information. So we'll start up with the setup. So you're going to import all the required libraries, and that's what you're doing here. A recommendation is to make sure you're always using the latest SDK version. So we do have releases that go out every 2 weeks. So just make sure you keep up with that, so then you get the best experience out of it. So for example, this notebook was using 1.90. We will be releasing, we're currently at 1.12 right now. So I definitely recommend upgrading your workspace and giving it a try. So once you do that, you could go ahead and call in your workspace configuration. And as I mentioned earlier, since all of that subscription detail, your workspace detail is already there, you don't need to do any additional setup. All you need to do is run the cell, give your experiment name, in this case, AutoML forecasting energy demand, and then just launch that, and it'll provide you with all the details about your workspace. The next step you'll need to do is attach an AML compute, and this is very similar to what we did in the UI. Before we launched our experiment, we had to make sure we attach compute. Same idea. So the workflow using the UI or the SDK is the same thing. The only idea is you get to use more code, and it's more flexible with the Python SDK, whereas with the UI, you just click through the buttons to get to your ML experiment. So and the next step here is that's what we're doing. We're attaching the AML compute. Once we do that, we could go ahead and start setting up our data. So in this case, we're doing an energy demand forecasting data. And as you know, too much energy consumed can lead to a waste of energy, and too little energy can lead to power outages. So they want to make sure they predict this accurately. So in this case, the target column is demand, and they also have introduced a new column called time column. And in this case, it's timestamp. And when you're doing a time series forecasting, this column is very important. So the next thing we're doing is calling in our data set. We have it stored in our blob store, so we're just calling in that. And remember, AutoML uses tabular data. So you'll need rows and columns for your data, and that's how we expect it to be. So we're going ahead, setting up our data, splitting up our train and test sets. That's what we're doing over here. Specifying a max horizon, in this case 48. So this is how far out we want to do our predictions. So in this case, I believe this is hourly. So we're doing 48 hours. And then over here, we kind of call out some of our AutoML settings. For example, task type, primary metrics for forecasting, how you can block some algorithms, experiment timeout hours, training data, label column, all that information here. And then you could go ahead and you'll see the settings. This is how our AutoML configuration will look like. So you see AutoML config, you specify the task type, in this case forecasting, primary metric in this case is normalized root mean squared error. We've blocked some algorithms. We set our experiment timeout hours to 0.3, and just some additional settings here. And the two main important ones here are time column names and max horizon. And then you could go ahead and launch your remote run. And what happens is you'll see all the AutoML runs from this page. So instead of having to see it from the UI, you can just see it from your notebook. But what's great about the UI is that it's all integrated with the notebook, so you can see it all together. So if you go to experiments, after doing the run from the notebook, you'll be able to access that information right from the experiments tab. So no matter if you run your experiments from a UI or a notebook, everything will be captured here. So this is your one-stop space to manage all your models, experiments, data, everything. And that's what I really love about the workspace. So let me see, I do have the AutoML forecasting energy demand run here. So I'll show you what that looks like. So we see a completed run over here. And in this case, again, the best model summary provides that voting ensemble is our best model. I could go ahead and click on that one. And then we can see all the additional metrics. We can see explanation for that specific run. And remember, we can see engineered and raw features. So I'm just going to let this load up so we can see this over here. And we are currently working on a different visualization. So if it does change in a couple months or so, don't be shocked. It's just something that's coming in our upcoming release. And then you could go to the metrics to see some additional charts and stuff. So again, all I'm trying to highlight here is that the experience is the same whether you use the UI or the notebook. Just if you want it to be a little more flexible or whatnot, or like if you prefer using code, I recommend using the notebook. If you prefer to get your experiment done within setting it up within minutes, I recommend using the UI. So that's basically what this lab highlights. And you go ahead and retrieve the best model, go through some featurization steps, and do some additional forecasting once you complete the main part of the lab. So that's basically what we highlight in this lab. And I know we have the session open until 12 o'clock. So if you have any questions, feel free to ask right now. If you want to give this lab a try on your own right now, I'll stay on the call so we could just walk through it together, if anything. Any questions? So I'm not able to monitor the chat right now, but if you do have questions, feel free to unmute yourself and just go ahead and ask.
Can you hear me?
Yes, I could hear you.
Great, thank you. I feel this is super great material, but do you mind slowing that a little bit?
Sure, yeah, of course.
Thank you.
Do you want me to go over any specific parts again?
No, that's fine.
Okay,
Thanks.
cool. Any questions, anyone else? So I could go ahead and paste some of the links in the chat. Let me see. And I guess that will give you access to our documentation and you could get started with more details. And most of our documentation links are actually already in here. So if you just go back. So if you click here, Azure Machine Learning Overview, what is that? Automated machine learning and our sample notebooks. Great links for you to get started with. And let me just go ahead and open some of them up for you so you can see what they look like. So this shows you what Azure Machine is like from end to end, provides details on our product, features, pricing, gives you links to our documentation, talks about some of our exciting customer stories and upcoming announcements. All that information you could find in this link over here. The next link that I want to highlight is the automated machine learning documentation. Let me just open that up. So you could find all our AutoML documentation over here. So it talks about what is AutoML, how you can get started, talks about what we support and all that cool information. Now, it's divided up into a couple sections. So we have concept articles, tutorials, and how-to guides. So I recommend you start off with the concept articles, and that's where you'll find AutoML overview. And then if you're ready to get on a hands-on experience, you could go ahead and try the tutorial. So we have both, one using the Python SDK, using a New York taxi example in the SDK, and the other one is the AutoML UI. And we have a couple examples of bike share data and bike marketing, which is what we're using in this lab. So once you get the gist of the tutorial, you could go ahead and you might start asking questions on what are the additional things I could do with the Python SDK versus a user interface versus different steps of the training process, let it be featurization or whatnot. So you could go ahead and access all of that from here. So you can find all that details here. And the final thing that I want to show you is our sample notebooks. So I did show you how you can access the sample notebooks from the studio, right from the notebooks tab, but you could also have access to all the sample notebooks right from the GitHub repo here. You can see what we offer for automated machine learning. So for example, this is a classification bank marketing one that we're using. We're using this data set for the UI, but if you want to give it a run using the notebooks, go ahead and try this notebook out. And each of these notebooks highlight different set of features, a different task type, and provide you with the different set of goals. So I definitely recommend go ahead and explore these. And once you know what you're trying to do with your data set, you could obviously go ahead and mimic these notebooks. Go ahead and just copy in your data and you can go ahead and get started. So that's basically what I have for you today. Let me know if you have any questions.
Yeah, hi. There are some questions. I think they're coming through the chat box. And one of the things is that I've been doing ML for a few years now, a couple of years now, writing my own algorithms from Python. I'm new to Azure, so as soon as I went to sign up for that session, it took me to a subscription page where I put in my company's information, and I can't find automated ML. There's another question that came up on the chat box about that. So if you can address some of the basics, I think some people may be embarrassed to ask that. But
no worries at all. Yeah. So there's two links that's highlighted right in the from the lab. So the first one you'll need to access is portal.azure.com. So I'm going to just show you that quickly. So let me know when you can see my screen. Hold up, let me just go ahead and share my screen. Okay, let me know when you can see my screen. I'm gonna guess you can see it now. So the first
yes,
link,
I can see it now, yes.
The first link that I'm showing you is portal.azure.com. and you'll need to search up machine learning. So as you can see over here, machine learning, this, and
Hold
go
on,
ahead.
let me try to get there, because I went to another where it says welcome to studio, or welcome to the studio. It wants the directory name subscription that I have to sign up for. So
Right,
for
so I think you're at ml.azure.com.
Yes.
Yeah, so the first step is that you need to make sure you have a subscription and also a workspace set up.
And I created that.
Okay, great. And then now once you go to ml.azure.com, you'll need to select, so in this case, it's going to go ahead to my workspace directly, but you'll need to choose your current subscription and also the workspace that you created.
Okay, let me try that, and I'll come back if I have additional questions.
Cool, yeah. And then once you go ahead and select that, you'll be able to see the screen. It'll say welcome to studio, and then you'll be able to access all of these additional stuff.
Now, does this support convolutional neural networks and maybe graphing networks and higher end algorithms too?
Not in the studio.
Okay.
Yep. Okay, I'm gonna have to stop sharing my screen to see the questions. So I'm gonna just jump onto the chat. So there's a question about the free trial account. So yes, you'll need to sign up to get the free trial account for your Azure subscription. Unless if you already have one, you won't need to do that step. But make sure you sign up first and get that account. So that's the only way you have a subscription. I believe you get around $200 credit for the month, then you could go ahead and give that a try. There's a question about data size limit. So we do support large data right now. I don't have an exact number on the limit, but how large are you trying to upload? I believe this is coming from Ashley. If you want to just unmute, feel free to do that. And there's a question if there are pre-recorded videos associated with this lab. Yes, there are. So we do walk through the end-to-end lab in the pre-recorded videos. Let me know if you have trouble finding that. So yeah, there's a lot of people asking about the data limit. How do I access AutoML in my workspace? It says it's locked behind an enterprise account. Okay, so if it appears that it's locked under an enterprise account, go ahead and upgrade your account to enterprise. You won't get charged for this, and you could go ahead and access all the features. So don't be scared to unlock that. Any other questions? So there's questions about the pre-recorded videos. Let me see if I could find that link for you, or let me check. We'll get the link in the chat once we find the link to the pre-recorded videos. Any other questions? So I noticed someone said they have a 38 GB data. So what type of task are you trying to do? So there's another thing that we support, which is called mini models. So especially when it's larger data and stuff, we'll recommend that you partition your data and build multiple models. I can paste the link for that in here, and maybe you could explore that if that works better for your solution. So currently our many models solution accelerator works with forecasting. If you're looking for classification or regression, do send us a note and I'm happy to help you get on board with that. Let me paste. So I pasted a link to how you can build multiple models using Azure Machine Learning. So that's what the link is. I see there's a question, where did you go after searching for machine learning? Okay, let me show you that. I'm gonna go ahead and share my screen again. So you're at portal.azure.com. Once this loads, you'll need to search for machine learning, and that's what I'm clicking on over here. And all the steps that you'll need to do is actually highlighted right here, so it should look exactly the same. So you go ahead, click create resource, click machine learning right here. Let me know if you can see my screen properly. Click create. And then you go ahead and fill in all the required information. So in this case, I already have a workspace, but I could go ahead and add one if I wanted to, and then fill in all the required information here. For example, choose a subscription, choose a resource group. I could go ahead and create a new one. Give my workspace a name. This is what we're going to be using in ml.azure.com. Choose a region I want to set this up in. Choose the workspace edition. So if you already set it up as enterprise, then you won't need to go through that upgrade step. And then you could go ahead and review and create it. That's all you'll need to do. Let's see. Shot. I'm just going to check if this is the link that, yep, this is it.
Hello and
Yeah,
welcome.
so you can just watch
everyone,
this
to
link to for the end-to-end presentation. I'll just paste this one. So I pasted a link to the video, the end-to-end one. It's like 45 minutes, so you could just run through it end to end. Kiana and Shanae from my team actually helped to talk through both the UI and the SDK, so you'll see them in the video as well. Let me know if there's any other questions.
Where's that link at? I didn't get that part. Where's the link?
I pasted the video link actually in our chat right now.
Okay.
Yeah, so let me know if you could access that.
Yes, I have it.
Great. Let me just see if there's.
Hello.
There seems to be two links, so feel free to access either one. So there is also directions on how you can access the links. So it's already in the chat, but I'll just say it out loud as well. So if you go to VFairs breakout session and then hands-on tutorial, you'll find a list of all the tutorials. And this one is called 3 from 0 to AI Hero. And you could access it from there.
So do you know in the actual automated ML, are they doing like a k-fold cross-validation with each of the possible ML algorithms that it uses?
Yeah, so what's happening is you have the option to choose which type of cross-validation. K-fold is just one of them that AutoML supports. Let me show you where you can find more details on that. Let me just paste that link in the chat. So yeah, the documentation I pasted talks about the different cross validations that we do and more details on how we do it.
And one other question, many machine learning algorithms based on Python and pandas, their normal, I guess, floating point size is 64-bit. And that can become a little bit computationally intensive and memory intensive. Is there a way to control the number of bits that each of the, say, the floating point numbers are represented by? Can you get it down to 32 or 16? Or is it an optimization?
Are you talking about algorithms based on data size or?
Well, when you read in the pandas data set, a CSV file, and
Yep.
you have a number of features in the columns per se.
Yep.
Pandas will try to determine what type of data that is. Is it a text? Is it a floating point number or integer, whatever, and read it in, I think
Yep.
by default as 64 bits. So when you start doing some of your computation, any kind of convolution, you know, the 64-bit may take a little bit longer to run on certain processors. And if you have a 32-bit, they may be able to do parallel processing where they may do 2 multiplies and 1 CPU, whatever. So there's a way to optimize the performance of some algorithms by using a lower number of bits. And it's good when you deploy it to certain inference systems or servers where they can use less computational sources. So is the system that advanced where you can actually tell it to use maybe floating point 32-bit representation, or it's all canned so you don't have access to that?
Yeah, so we kind of do it a little differently. It might be a little similar, but based on the data size, for example, so we do have some large data algorithms that get kicked off based on if it is required based on data size and all. Now, if it's like a text data or not, we do have like support for that, but based on large data support, you will need to either allow these algorithms or block all the other algorithms, and then that way it kicks off based on, that's how we do our large data support. Now for the bit support, I'll need to follow up with you for that question specifically.
Okay, thank you.
There's a question on the chat. So when creating a new compute to configure the run, I met an error trying to select the VM size. So yes, so it looks like you ran into some quota issues. So my recommendation here is one, you could either use a smaller VM or you could ask for additional quota. And you should be able to run an AutoML experiment using one of the smaller compute sizes. So just choose a smaller VM size and you should be able to go ahead. Oh, it seems to be blocked. Do you mind screenshotting your screen for me maybe? And I could take a look at what you see. So if you can't select anything, I recommend requesting more quota. But if you are using the free trial, it should allow you to do that. So when you mean customized model optimization, do you mean the choice of model? What do you mean by that? So there was a question.
I mean, like,
Yeah,
if
go
I
ahead.
build a model myself, is there a format where I can upload the model to the platform and let the platform help optimize parameters?
I see. I think you're asking about like bringing your own model, for example. Is that what you mean?
Yes.
Yeah, so that's something that's on our roadmap. If you do watch the video, you would see we talk about that. In our roadmap, we do hope that you would be able to bring in a model and train it along with our AutoML algorithms, and then it will return the optimized model for you. So that's something on our roadmap.
Cool. Thank you.
No worries. Any other questions?
So I'm back to the page of the AutoML on the portal azure.com, and it has the Azure Machine Learning Studio. And when I go there, it goes to enterprise where it wants me to upgrade. I have to basically click on that to upgrade to
Yep.
enterprise.
Exactly.
Okay.
Feel free to keep the questions coming in the chat. We are monitoring it. And anyone who joined a little later, feel free to like run through the lab right now. So you can find all of that over here, all the steps on how to do it. If you do run into any issues or anything or have any questions, I'm happy to answer it while we're on this call. And if anyone has any questions about any of the parts we talked about previously, feel free to just go ahead and ask. So I see you sent the screenshot. Subscription, and then are you using the free quota, or have you already used this already? Is this something you've already used, or? So I'm just gonna quickly share my screen again. Just so if anyone else runs into quota issues. So you have a couple options to create your compute. One, you could do it directly from the AutoML run. Another option is to just do it from here. Go to compute clusters, click new, choose your compute name, and then you'll see the different things that are available here. And if you actually have nothing available, so you can see some of these are not available. These are like the larger sizes, but the smaller ones are actually available. So do you not have any of the D11s available either? And if you actually don't have any additional available, you'll need to go to portal.azure.com. And then I believe if you access the actual workspace, you should be able to request for quota. So you go to usage and quota from the workspace, by the way. So I'm going to the workspace, I selected ANUMAMEH. I clicked on my usage and quota, which you'll find under support plus troubleshooting, and then you'll see your availability. So this is what I currently have. You'll need to request if you need more. And then you could just request a quota from here. Oh, you created a support request? Okay, cool. You already created as requested for quota. Yeah, it looks like they're pretty full, but the D family you seem to have some. Should work. Any other questions? You could give that a try. If you switch it to low priority and if you could select something, go for it. Give that a try. Yeah, and then go for it. Feel free to speak up if you have any questions. I'll be here, so. And if you want me to walk through the lab again, I'm happy to do that. So feel free to ask for that as well. It shouldn't be a problem if you set it to 1. That should be fine. The only problem is training might be a little slow, but that should be fine. So did any of you get through lab 1 yet? Or are we still setting up our workspace?
I'm at the part where I'm checking the schema of the actual variables that are loaded in from the initial
Okay.
test data set.
Okay, great. You're on lab part 1, right?
Yes.
Okay, perfect. Okay, great.
I have a question. I forgot to remove the day of the week, and I'm trying to get back to that initial test data set to remove that.
Yep. So you could go back, that's an option.
Back doesn't seem to, okay. Well, select data, so, okay, let me see, going back.
So there's the option there. Another option is that when you go to the feature customization step, you could go ahead and remove that column. Like, let me see.
So I'm at the place where I selected data set.
Okay. You could just skip through that step as well. Go to the next one. And then once you get to the part where you select your task type, you'll see classification, regression, and forecasting.
Okay, I'm at the place where it says configure run, and I can view the data set.
Let me just open up to the same screen as you, and then I'll share my screen.
Okay.
Let me know when you can see my screen.
You see it now?
Okay, perfect. So you want to remove a column, right?
Yeah, so, okay, so you're past the configure run. I see that. I haven't gotten there. I'm at create new experiment name. So I need to do that.
Yep. Once you do all of that, and set up your target column and choose your compute cluster, you could go ahead and do that.
So target column is this prediction column, and it could be anything I want.
Yep.
Okay. So I'm at the place where I'm doing the new compute cluster, and I selected low priority,
Okay.
and I don't get a create option with the standard settings.
So you don't see any option at all for any of them?
No, I see that the standard set. Oh, I forgot to give the computer name. Okay, do that. Okay, I got it.
Okay.
So what is the Y target column indicative of?
So in this case, it's whether they will get the term deposit or not. So that's why we set it to Y. It's yes or no.
Okay, so I'm on the create a new automated MO run, the task type and settings.
Yep. And then if you do view featurization settings in the bottom, you should be able to include or exclude a column that you don't want to include in your predictions.
Okay, I'll go ahead and look for day of week and turn that off. So it's disabled, and I'll save that. And then that should be about it, right? So enable deep learning, is that for the CNN type thing, neural networks?
Yeah, exactly.
Okay, so keep it disabled.
Yep.
So does this also include like random forest classification options?
So if you go to view additional configuration settings, you'll see all the types of algorithms that are going to be used for this run, but you could go ahead and block some of them if you don't want to use it.
Okay, let me see where that is. So I'm on the page where it has the run one, not started, so forth. Where is the additional?
Are you at the page before you click finish? Like, are you at the same screen as me right now?
No.
So I'm going to assume you launched your run already.
Excuse me?
Did you click finish already? Is that what you did?
Yeah, yeah.
Yeah, so when you do create a new one in the future, if you click on view additional configuration settings, if you can see my screen right now, and then you block the algorithms that you don't want from here, the screen, that way you would only see the algorithms that you want on there. And depending on the task type, for classification, we support these algorithms, but if it's regression or time series forecasting, you'll see a different list.
Okay. And are they doing sort of automated hyperparameter selection where they go through and test hyperparameters and see which ones are optimum?
Exactly. But so if you prefer to do something just with hyperparameter tuning, we do have a separate offering called Hyperdrive. And in that one, all you do, it just tunes the parameters. So you'll provide the algorithm, and then it does the hyperparameter tuning and returns the model for you. Whereas here we do both the algorithm selection, hyperparameter tuning, featurization, and return the model for you.
In some of the hyperparameter selection algorithms, it actually sets up a range of values and a step size. How are you guys handling that? Because I got to a point where I had a k-fold cross validation of 5. I had thousands of features and millions of columns or rows, and it took forever to run based on the resolution of some of the hyperparameters. They would have maybe 20 different variations of the models times across 5 validation. So 100 tests they had to run. How do you guys limit the granularity in the hyperparameter selection?
Yeah, so I don't have the exact details on how you can limit it, but I do have details on how you could get information on what was done behind the scenes. So let me share the link for that with you. And also, like if hyperparameter tuning is something that you really want to focus on, like I guess exploring the hyperdrive docs would help. So let me just share that as well. So 2 docs right there that would help you. And if you do have any follow-up questions, I could connect you with the program manager working on hyperdrive to help you answer those questions.
Okay, thank you.
So let me just open that up for you. So I pasted a link on how you can tune your hyperparameters. So this is just using hyperdrive specifically. And I'll find the link on how you can see what's happening behind the scenes.
So I think I have one final question. I'm on the page where it says run one is preparing. Well, is it looking for computer resources to make the run of the training?
Sorry, it says run one is preparing. Is that what it says?
Yeah, it has like two curved arrows and says preparing.
Yep, that's good. So that just means it's going to take some time to set up your run. It's going to spin up your compute. It's going to go through the featurization step and then slowly make its way to running state. Once it's running, once it's completed training all the models, you'll see it says completed under each model, and then you'll see your recommended model and it'll say completed.
So under the view run settings, I was looking for the number of cross validation and it's blank, 2 dashes. So
yeah, so I think if you give it a couple minutes, you'll
okay.
eventually see it.
Okay, thank you.
So you probably left it on default settings. So from my previous bank marketing experiment, used Monte Carlo, but from the additional configuration settings, you can specify which type of cross-validation you want it to use. So when you do a feature run, you can go ahead and choose your cross-validation.
It's usually Monte Carlo. I'm not familiar with that one. I usually use full cross validation, but I can probably look at it and see what it does.
Yep. So there's a question on the chat about how did we resolve the issue of not having enough quota. So you have a couple options here. One, make sure you have filled in the compute form correctly with the name and everything. Secondly, if it says dedicated, switch it to low priority, and then it'll provide you with details on how much quota you have. And if that doesn't work, your final option is to go to portal.azure.com, click on the machine learning workspace that you created, and then from there, go to quota plus, let me just double check the name again. Go scroll down on your machine learning workspace to support plus troubleshooting. In the sidebar, you'll see usage plus quota. And from there, you would be able to request for additional quota. I don't think this is required, to be honest, but yeah, switching it to low priority should fix it. Feel free to let me know if you do have any questions or if you're running into any issues. So we're still here, even though it's super quiet. So just let us know. And if you want, I could play the video for you guys to watch, if that helps as well.
So my job eventually started running. Will there be an indication when it's completed and where the results are?
Yeah, so right from that page, you'll see, I'm hoping you're on the run details page. You'll see that right now, if it's running, eventually it'll go to completed right from that page. And then you'll see the recommended model right on the side tab. So you'll see the run details, best summary, and under there, you'll see the best algorithm. And if you click on that, you could run into the additional details, like for example, explanations, metrics, and all those additional visualizations.
Okay, so will it provide like a training accuracy and a validation accuracy also?
Just
And
the training accuracy.
just the training accuracy?
Yep.
Okay. Why not the validation? Does it normally should split it between like say 70-30, 70%
Yeah.
data, so it does that?
Yeah, that's something on our roadmap to provide details. So a couple things is one is being able to provide a test set and stuff from the UI. All of that would be part of, probably will be in the next 6 months, hopefully. But currently you can only see the training accuracy.
Okay. But the overall goal is to predict based on the given features, if this person be given credit or whatever. So it should be able to take some amount of that data and say, well, I don't know what the actual result is. Let me give it the raw data, raw features, run your model and see if it actually correctly predicts whether or not this person was, given a bank credit.
Yeah.
So do you get that result from, you don't get the result from the validation segment?
So we do, so if you want to do that whole testing part, we do have a couple options. One, you could do it from our notebooks. Another option is to do it with Power BI. We do have an integration to do that. But the part that you're asking for is something on our roadmap, which
Okay.
yeah. I do see another question on the chat. It says, so just to check for lab number 1, we're waiting until the experiment run to finish before deploying the best model. Yes, that's correct. So once your model has completed training, you'll see a green check mark with the word completed right next to it. You could go ahead and deploy your model once it's at that stage. So I guess since most of us are waiting, I could play the video. I'll share my screen and play the video. And then you get some details into some of the other additional features. So I'll go ahead and play that. Feel free to interrupt me and keep asking questions on the chat window. I'll reply in the chat.
Hello and welcome everyone to our KDD session from zero to ML Hero using automated machine learning. We're so glad to have you join us virtually today. Before we begin, I want you to meet the team of presenters. My name is Aniththa and I'm a program manager on the Azure Machine Learning team here at Microsoft. I'm also a graduate from the University of Waterloo. My latest mission is to accelerate and democratize AI using Azure Machine Learning.
Hi everyone, my name is Shanae Winner and I'm a program manager on the Azure Machine Learning platform team. I graduated from the University of Pennsylvania where I studied system science and engineering. And currently I'm working on improving the training experience in the Azure Machine Learning experimentation UI, where data scientists can track, monitor, and compare their machine learning training jobs. And I'm really excited today to talk some more and to share about Azure Machine Learning and also automated machine learning.
Hi everyone, welcome. My name is Kiana and I am a program manager in the Data to AI team. I graduated with my PhD from Iowa State University, studying computer science and working on machine learning models for big data. Currently, I work as a user experience program manager in the automated machine learning team, and I try to understand and fill in the gaps in the user flow when using the machine learning studio.
Now that you have met the team of presenters, I want to give you a quick overview of what's on the agenda for today. We'll start off with the intro to machine learning, talk about why automated machine learning, dive into the capabilities, see what's on the roadmap, and finally, Shanae and Kiana will walk you through some personas as we go through lab part 1 using the AutoML UI and lab part 2 using the AutoML Python SDK. Let's begin. As we all know, AI is everywhere, and it has begun to touch every industry. It can be simple as figuring out the price of a car, or figuring out how much money you have in a bank. As more industries rely on big data to make choices, data science has become increasingly important across all industries. And we know not everybody can become a PhD in stats and data science. AI and machine learning need to be democratized so it will be accessible to anyone. Just like cloud computing was fundamental in the explosion of startups, machine learning democratization will likely power the next generation of applications crafted by developers, but also directly used by consumers and business tools. So let's take a look at the machine learning process. As a developer new to machine learning, I want to simplify and streamline the model creation process because building models can be tedious and iterative. You select features, choose algorithms, and set up hyperparameters, then iterate on the data many times until you get to that satisfactory model. For example, let's say we want to figure out the price of this car. How much is this car worth? And let's just say we're optimizing on the metric accuracy. So the first thing you'll need to do is choose your features, choose an algorithm, and tune your parameters a certain way. So since we're trying to figure out the price of a car, let's just say we go with car brand, mileage, and year of make as our features. Maybe choose gradient boosted as our algorithm and tune up parameters like this. And this returns a model of 30% accuracy. As you can tell, that's definitely not good enough. So what we'll have to do is choose different features, choose a different algorithm, and tune our parameters differently, and this returns a model of 50%. Definitely better than before, but we know we can definitely do better. So we'll continue to iterate until we find that optimized model of 95%. As you can tell, this is a time-consuming process. The current process needs practitioners who are skilled in ML, such as data scientists. What if we can simplify this process? What if we can enable those who are novice in the area to create machine learning models? What if we can enable those same skilled professionals to be more efficient and productive? And that's exactly where automated machine learning comes in. Automated machine learning picks an algorithm and hyperparameters for you and generates a model ready for deployment. The model then can be downloaded to be further customized as well. So let's take a look at the automated ML mission. Our goal is to enable automated building of machine learning with the goal of accelerating, democratizing, and scaling AI. So what we actually mean by this is, let's just say you have a data science team with varying levels of experience. With AutoML, you are able to expedite the entire data science process. This is where the democratized AI piece comes in. Now, if you have a smaller team of data scientists, with AutoML, you are able to make the most out of the limited resources. Thus, you can improve the productivity of the data scientist. We have also seen scenarios where customers want to build multiple machine learning models in parallel, and now they can do that in an automated way, which we mean by scale AI. So let's take a look at what automated ML is actually like. So with AutoML, all you'll need to do is bring in your data set up some configuration and constraints. So say you're going to run a classification, regression, or forecasting task. Maybe you want to only run it for 3 hours, and you also choose a metric that you want to optimize on. Let's just say accuracy, similar to the car example we did earlier. AutoML will intelligently test multiple models in parallel and return the optimized model for you. So let's actually talk about how this works. AutoML is based off of Microsoft research. The brain has been trained with several millions of experiments. I kind of like to think of this like as Netflix, where after watching some movies, you'll see that it recommends the next movie that you might actually want to watch. What AutoML uses is collaborative filtering and Bayesian optimization. It currently supports classification, regression, and time series forecasting task types. So now that we know what automated ML is, let's dive deeper into the capabilities. So automated ML is supported with a Python SDK as well as a UI. If you're a data scientist, you will be comfortable using the Python SDK in Jupyter Notebook, and you'll be able to use Jupyter Notebooks from the Azure Machine Learning Studio. If you are a citizen data scientist, or if you just started making your way as a data scientist, or if you prefer graphical user interface over coding, you can use the automated machine learning web user interface in the Azure Machine Learning Studio and start a training job within just a few clicks of a button. The data requirements for automated ML is a tabular, or we could call it flat data. We expect a single flat data set, and if columns aren't named, we will name them as column 1, 2, and so on. We do have several sources for your data to be brought in from, and we will cover that later when we're walking through our demo. Automated ML does support large data, and another thing that you could do is enrich your data with Azure Open Data Sets. For example, let's say you're creating a predictive model to forecast sales on a retail store. Weather data and holiday data can have an impact on your predictions. And now you can take advantage of Azure Open Data Sets to add in public holidays or historical weather, US population into your predictions. And we also do support data guardrails. So we do some detections of class imbalance, train test split, missing value imputation. We detect high cardinality features, detect leaky features, detect overfitting, model interpretability, and feature importance. As we all know, data and featurization play an important role in the model creation process. And when it comes to automated machine learning, we do both automatic featurization and allow you to do customized featurization. So when it comes to customization, our value prop is to enable data scientists with knowledge on how the data contribute to the model. And this will essentially result in better accuracy. So some of the things you can do with customized featurization is block transformers, override column purpose, choose to include or exclude columns in training, and decide how to impute missing values. Additionally, we do support deep learning with BERT and BioSDM for NLP. To learn more about our advanced data preprocessing and feature engineering, definitely check out our docs. When it comes to training, as I mentioned earlier, automated machine learning currently supports classification, regression, and time series forecasting task types. We have added world-class statistical models like ARIMA, PROFIT, and deep learning models like TCN. We try all of these along with our classical models on the user's data set to provide better performance. Another new capability is many models. Now, instead of having one model to forecast for your entire store, we are introducing grouping, which is our first step towards hierarchical time series. This will allow for more detailed forecasts. And the final capability that I want to talk about is interpretability. Often when you're done training your model, you'll get questions like, what did you do and how are the predictions made? We want to make sure the entire training process is transparent. So we now support interpretability dashboard. So you're able to see which features played an important role in the predictions. You're able to do this for both your raw and engineered features. And we provide both a local and global feature importance chart. You're able to do this at both training and inferencing time.
So now let's go ahead and see what's on the roadmap for the next 6 to 12 months. To start off, in order to improve our transparency and customization story, we will be supporting code generation, allowing you to take an experiment from the UI or an individual iteration and generate code out of it in order to further customize your model. The next thing is componentized featurization, allowing you to use featurization on your own models. We also are looking to support bringing your own model and also a many models authoring UI experience, allowing you to build multiple models right from the UI. Finally, we have some forecasting enhancements with hierarchical time series support on our roadmap.
Now that we know more about what AutoML is, we move on to understanding who can use the product. So we have seen the demand for AI is growing, and we're talking about making it as accessible as possible. Now let's talk about what that actually looks like. You can see on the scale here, the y-axis, we go from no ML experience to a machine learning expert. On our x-axis, we see the coding comfort and preference from no code to code. Now let me introduce to you our 4 personas. On the top of the quadrant, we have our machine learning pros. They have been in the space for some time and they're looking for ways to better their workflow. On the bottom, we have no ML experience. These guys are domain experts who really understand their business and they just want to know what ML can do to help them. Now let's talk about a specific use case. So Raj is a fluent business intelligence and data scientist. He understands what ML can do for him. He does not have the time to experiment with creating and tuning the production models, but he wants to get started quickly. What is the problem he's trying to solve here? The data that he has is related with direct marketing campaigns of a Portuguese banking institution. The marketing campaigns were based on phone calls, often more than one contact to the same client, in order to access if the product, which here is the bank term deposit, would be a yes or a no. That is stored in the Y column. Now we want to see how we can make a model based on this data and use it to predict the answer to the question, will this client be getting a deposit? Let's see how we can help Raj do that in the bank marketing automated ML UI lab. So this is the GitHub page. Here you can find, you have access to the first lab and the second lab if you want to run them yourself. Now, in order to actually go ahead with the lab, we have some prerequisites. The first one, obviously, is having an Azure subscription and an Azure machine learning workspace that will show you how to create below. To create a workspace, you first need to go to the Azure portal, which is portal.azure.com. When you go there, you sign in with your Azure subscription credentials and then try to create a workspace. Now, how to create a resource? First, you click the create a resource on the bottom left of the path. Then you search for machine learning. And when you find it, you click on create. This way, you can make your own workspace and we will later use it in the studio to be able to run the lab. The fields that you need to fill out is the name, the subscription, which is the Azure subscription that you have, your resource group. You can use an existing one or you can create a new one, the location, and the workspace edition. For this tutorial, you would be able to use basic, but you can also upgrade to enterprise for more options. After that, you just click review, create, and your workspace is ready. Now let's go ahead with the lab. Welcome to the Microsoft Azure Machine Learning Studio, a consolidated web interface that includes machine learning tools to perform data science scenarios for data science practitioners of all skill types. In this lab, you learn how to create a basic classification model without writing a single line of code using the Azure Machine Learning's automated machine learning interface. This classification model predicts if a client will subscribe to a fixed term deposit with a financial institution. With automated machine learning, you can automate time-intensive tasks. AutoML rapidly iterates over many combinations of algorithms and hyperparameters to help you find the best model based on the success metric of your choosing. So let's get started. So first, we sign into Azure Machine Learning at ml.azure.com. You choose your directory, your subscription, and your workspace. And let's get started. This is the Machine Learning Studio. On the left side panel, you can see different authoring experiences, assets, and manage your resources. The different authoring experiences we offer at the moment are the notebook experiences, automated ML, and designer. Automated ML will be what we will be giving you more information on in this lab. Your assets are your data sets. You can upload and register any data set here and use it for your machine learning experiments. The experiments will be all the machine learning jobs that you want to run with access to information about each of them. Pipelines is going to be the place that you can create workflows in your projects. Models will be where your registered models and any versions of them will be stored. Finally, endpoints would be where your deployed machine learning models as a web service will appear. You also have the option to manage your compute instances, your blob or data stores, and label your data. Now let's get started with our automated ML. If this is your first time using automated ML, you will see that this panel would be empty and you would have access to the documentation right here. So how we start this process is by clicking the new automated ML run button. So the first option would be to have the data set for your experiment. I already have that data set in my hard drive. So only thing I need to do here is to create a new data set from local files. I'm going to give this data set a name. I am going to call it bank dataset 1. You can add any description that you want. Customer call info. We go to the next step. Now you need to select a data store. The default version here that we are also going to use is the workspace blob storage or Azure blob storage. You can use browse to use your select your data set here, and then you can just click next. This is going to take several minutes depending on how big your data set is to upload this file and make sure that it has the schema and everything ready. Now that the data set has been uploaded, we move on to the next step, which is configuring the schema. The schema is technically every feature that appears in your data set appears here. Now that the data set is done uploading, we can put the names and the settings there. So the file format here for this specific data set is delimited with a comma. In different data sets, that could be different. Encoding is UTF-8. Now, column headers. Do they all have the same header or do they have different ones? They have the same one for this one. Do you want to skip any rows here? No. So now here you can get a picture of what your data set actually looks like. ID, job, marital status, education, housing, loan, and all the information you have for each customer. We go to the next step, which is the schema. Here you have the option to either include or not include a specific feature. For example, here, we don't really care about the day of the week the call was made to get the information from the customer, so we choose not to include it. And the next step is confirming the details. You see all the information, and if you want, you can go back and change them. When you check everything, you press create, and your data set is being created and is right here for you to use. If you actually click on this data set, you have the option to preview the data right here in AutoML. You can see each data point, your features up here, and get a good look of what it looks like. After choosing the data set, we go to the next step, which is configuring the run. Here, you have the option to either select an existing experiment or creating a new one. Here, I'm going to create a new experiment. I'm going to call it bank Experiment 1. Target column is going to be the column that we want to predict. Here, we want to predict the answer to the question, is the customer going to say yes to having a fixed term deposit? So Y, which is that column, is going to be our target column. Then we have the option to select a compute cluster. You can either choose a compute from your list, or you can make a new compute. You can give a new name to your compute. I'm going to call it compute 3. And you can use the virtual machine size here. There are a lot of options you can choose from depending on how many cores you want, how many CODA, and the disk space. I am going to use D12V2. Minimum number of nodes I'm going to put as 1. Maximum number of nodes I'm going to put at 0. And then I'm going to click on create. Now be careful, this is going to take several minutes to actually go through. And so because I don't want to bore you guys, I'm going to use one of my other compute clusters to go through with this experiment. And then I go to the last step of the run, which is selecting and configuring the task type. So because the problem that we're trying to solve here is a classification problem, that's the one we will choose. Then we will go to additional configuration settings. Here is where you get to be picky about what do you want to track. Your primary metric that you want your algorithm to find the best model out of, you can choose from the drop-down menu here. Do you want accuracy? Do you want AUC weighted? Average precision score weighted? I'm going to use AUC weighted for this one. If you want to block any certain algorithms that you think might not work for your data set, you can do that right here. There's a list of all algorithms here for you to choose. Exit criterion is when do you want the AutoML run to end if you haven't gotten to the answer yet. So I'm going to choose that after 1 hour, my AutoML run is just going to stop. And for validation, you can choose cross-fold, K-fold validation, Monte Carlo, or train validation split. I'm going to choose K-fold validation with 2 as K. Concurrency is going to be the maximum concurrent iterations that can happen in this run. I'm going to choose 5 because I have 6 nodes in my compute. After I press save, I come back to the task type. If you want, AutoML has the option for you to do additional featurization. Here, you can again choose to include or not include certain features. You can also choose to impute that certain feature with impute missing values in that certain feature with different means, max, or just a random integer. If you don't do that, AutoML does the automatic featurization for you. And when we click finish, the AutoML run is starting to prepare. So as you can see the status here, it has not started yet. What is going to happen is the AutoML run is going to get preparing the data, preparing the compute target. If you want to keep updated on what is happening, you can click the refresh button here. As you can see here, it's saying starting. And right now, it's in the preparing stage. This will take around 20 minutes for the compute to get started and 2 to 3 minutes for each iteration to run. Of course, I don't want to keep you guys here for that long, so I'm going to show you an experiment that I ran on the same data set and is done right here. So whenever you run an experiment, it will show up under the Experiments tab. If you click on the Run ID, it will open the Run Details page. Here you can see the status of the run, duration, and any other detail you need. On the right-hand side, you see the best model summary. Here, for this specific run, it was this specific algorithm. You can also see what your metric was. If you want to see other metrics, you can open, and all the other metrics here will open in the side panel. You also have the option to look at the task type and any other run settings that you put here. And we move on to the models tab. Here you can see all the child runs that automated ML ran for you to find the best model. So right now, all of these are sorted descendingly by the metric that you chose. So the best model will always be on top. Let's just click on the model and see what happened. This model is a max absolute scalar model algorithm. And you can see your metric here is 0.95. Now, if you want to get more information about this model, you can go to the metrics tab. This metrics tab actually lets you see visualizations for different features. So here you can look at the accuracy table. You can see the precision, you can see the ROC, you can see the calibration curve. You get to play with all these visualizations on the side here. Back in the Models tab, you have the option to deploy the model with the click of a button. You just need to fill in the name, description, and the compute type. We're not going to get into this here, but Shanae will go through this with the SDK. After you deploy the model, they will end up in your endpoints right here. The lab is now complete. In this tutorial, you used Azure Machine Learning's automated ML interface to create and deploy a classification model. If you want more information, you can always check our documentation at docs.microsoft.com.
So before we move on to the next section of the lab, I was just wondering if anyone has any questions in the call. And feel free to just post your questions on the chat as well. I am monitoring that, so we'll reply to you if you have any questions. I'll start the video again.
In the Models tab, as we said, the best model is here for you. This helps you understand what features are directly impacting the model and why. Here you can see the top 8 features that are contributing to the predictions that this model has. You can see them right here. And this is really useful if you want to compare performance of several models together.
So previously you looked at some personas, but let's revisit these personas again and focus on someone like John. So John here does not have much machine learning expertise or experience, but he does have some experience with code and he's comfortable working with code. In lab 2 of this demo, we're going to focus on an energy demand forecasting use case using automated machine learning SDK. So this scenario focuses on energy demand forecasting, where the goal is to predict the future load on an energy grid. This is important for companies in the energy sector, as operators need to maintain the fine balance between the energy consumed on a grid and the energy supplied to it. Too much power to the grid can result in a waste of energy or technical faults. However, if too little power is supplied, it can lead to blackouts or even leave customers without power. So John understands the business needs, and he has a basic understanding of how machine learning works. John does not have the time to experiment with lots of different models or even create and tune production models. Also, John wants to get started pretty quickly. So I'm going to walk you through one of our labs that focuses on the energy demand forecasting task. So let me switch over to the browser here. And right now I am in GitHub, where you can find lab part 1 as well as lab part 2. You previously created a machine learning workspace, which is needed to run this lab. You can create this workspace either through the SDK or from the Azure portal. And you would have already created a workspace if you did lab 1. The next thing that you want to do is you want to create an Azure Machine Learning compute instance. A compute instance is a fully managed cloud-based workstation, which is really optimized for your machine learning development. So compute instances are fully integrated with the machine learning studio as well as the workspace. And it can save you time for setting up tasks since it's already pre-configured with up-to-date machine learning packages and frameworks. So you can create a compute instance from the Azure Machine Learning Studio UI. So if you click on the compute tab, you can select new here. And this will allow you to create a new compute instance. You will need to specify a compute name and then choose the virtual machine type as well as the virtual machine size. And then you could go ahead and create that compute instance. I have already created a compute instance called AutoML demo, as you can see here. So I'm actually not going to create that instance, but instead I'm going to use this pre-existing compute instance here. So next you want to click on Jupyter Lab, which will take you to your Jupyter Lab here. And you would want to clone the repo so that you get the notebook as well as the other files for this lab. So in Jupyter Lab, I've already created a new terminal, so you can go ahead and do so by selecting File, and then New, and then selecting Terminal. You want to ensure that you're in the right directory so that the files are copied to the right folder that you're working in. And then what you want to do is copy this command here, and you want to paste it here and press enter. As you can see, I'm cloning over all the files. It should take a couple seconds. It looks like it's complete. As you can see here, I have my folder. Let me navigate to lab part 2. And then this is the notebook that we're interested in for this lab. So let's select the kernel that we want to use. So we have an Azure Machine Learning kernel with already the SDK installed and other packages. And we're going to use that to run this notebook. So in lab part 2, we're going to use the automated machine learning Python SDK to build a machine learning model where we're going to do some forecasting using the energy demand dataset. So we're going to use the New York City energy demand dataset, where our goal is to predict the energy demand for the next 48 hours based on some historic time series data. You would have previously created the Azure Machine Learning compute instance, as well as created the AML workspace. So let's get started with running this notebook. In this notebook, we're going to create an experiment using our existing workspace. We're going to configure AutoML using the AutoML config. We're going to train our model using Azure Machine Learning Compute. And then we're going to explore our engineered features and results and explore the models created. So step 1, we need to set up our training job. So in this cell, we are bringing in and importing all the required libraries needed. We can then print to see what version of the SDK that you are using. Next, I want to call my workspace from config. This is something that we have already created. And I need to create an experiment. An experiment is just like a container for your run history or like a folder for your runs. And in this case, we're going to name our experiment AutoML Forecasting Energy Demand. And I've printed information here for our subscription ID, workspace, resource group, location, and run history name. Next, I want to create an Azure Machine Learning Compute or attach an AML compute if we have already created one, or if you've already created one. So a compute target is really just a designated compute resource or environment where you run your training script or host your deployed service. So your compute target can automatically scale based on your experiment needs. In this example, The compute target that we're creating is called energy cluster, and the size of this is the standard DS12v2. I've previously created this compute cluster, and I've previously ran this notebook. So I'll just talk to what we're doing and walk through the notebook and the steps here. Next, we're going to look at our data from the New York City energy consumption. And we want to specify the target column, which is what we want to forecast, as well as the time column, which is the axis along which we want to predict. We also see that our data set is currently in blob storage. And we can then remove any missing energy demand values from our data by running this cell here. Next, I want to split the data into training and test sets. So it's important to note that we are actually splitting these data sets based on time. So any data before and including August 8th, 2017 at 5 a.m. will be used for training, and data after that time will be used for testing. So we've done that in the following cells. Then we want to set the maximum forecast horizon. And the forecast horizon is the number of periods into the future that the model should predict. So essentially, this is how far out do we want to do predictions for. So you can specify weekly or monthly data or hourly. However, in this example, we are going to specify the max horizon to be 48, as we did here in this cell. Then we want to train our model. So first we need to instantiate the AutoML config object. So AutoML supports tasks such as forecasting, regression, and classification. And in this notebook, we're going to do forecasting. You can also specify other properties such as a primary metric, which is just the metric that you want to optimize. The other properties that you can specify, like for example, the experiment timeout hours, which is the maximum amount of time in hours that the experiment takes before it terminates. So here you see where we're specifying the task to be forecasting, the primary metric to be the normalized root mean squared error. We also specify the time column, name, and the max horizon, as well as some other properties. I then want to submit my experiment, so I've done that here, and then I've submitted it on my remote compute target, which we previously created. When you run these cells, you should see a link to the Azure Machine Learning Studio. Here you can see the results of your experiment as well as monitor the status of your experiment. So if you select this link or you click on that link, it will then take you to the Azure Machine Learning Studio UI. In the Experiments tab, you should be able to find your experiment, which is the AutoML forecasting energy demand. And here, that link takes us to our parent run. In the details page, you can see the best model summary. In this case, that is this model here, the standard scalar wrapper decision tree model. You can also see the best metric logged. And if you click here on view all other metrics, you can see all the other metrics that were logged. If you select the Models tab, you should be able to see all the other models that were explored. So it's currently loading, but here you can see all the other models that were explored, and then you could click into these to get some more information. But you can see the best model here for your experiment is currently listed on the top. If you click into that model, you can go ahead and actually deploy this model from the UI. So if you select deploy, you'll need to specify a name, an optional description, the compute type. So there you can select AKS or Azure Kubernetes Service, and this is for production workloads, and or ACI, which is Azure Container Instance, where you would want to use this for like testing. So I'm not going to walk through the deployment phase, but you can do so from the UI. You can also click on some of these other tabs for more information, like for example, the Outputs and Logs tab, which should show you all your logs for your runs. And you can use these for troubleshooting or viewing any errors. So I'm going to jump back to our notebook. And then retrieve the best model, and you could retrieve the best model by using the get output method. And you can then perform some featurization, so you can access the feature, you can access the engineered feature names in the time series featurization. So as you can see here, you can see the raw features and transformation done to the raw features. In this example, you can see that the following information is displayed, such as the raw feature name, the number of engineered features formed out of this raw feature, the type detected, you can see where the feature was dropped, and you can also list feature transformations for the raw feature. There's some more steps in this notebook that you can explore, such as evaluating your model and looking at the predictions of your model from your test set, and as well as exploring some of the other visualizations in this notebook. I'm going to jump to our PowerPoint here, and I want to revisit John. And John, if you remember, was the persona that we were previously discussing. We saw that John had some familiarities with machine learning, but he wanted more control over his experiments. We also learned that John knows how to code, but he didn't really know exactly what algorithms will be best and what hyperparameters to choose and to tune. We also see that he was familiar with the data available in the organization as he has used it for building reports and insights. So John can use the automated machine learning SDK, and he can use this and use the same data that he's already familiar with from other areas. He can also communicate results and insights with the data science team to get approval on approach, and he can actually learn more about his model, like getting model explainability. I hope you found this demo useful, and I hope you try out automated machine learning SDK.
We're going to go ahead and revisit the personas again, and the final persona that we're going to consider today is someone like Danielle, who is an ML expert and knows how to code. So to give you a little bit more detail about Danielle, she is a data scientist with a good background in machine learning. She is familiar with Python code. She often tunes algorithms and creates machine learning models using notebooks. She frequently runs out of computer memory on her local machines, and let's see what we can do to help Danielle out. So for someone like Danielle, we would be using what is called automated hyperparameter tuning. This is the last offering we will explore, and it has to do with hyperparameter tuning. So let's start with a quick and brief overview of what it is. You all might be aware that deep learning and in traditional machine learning scenarios, the performance of a model you end up with relies heavily on the actual values of hyperparameters. And so when users are building models, they typically go through what's called hyperparameter exploration. This is the act of going through different configurations of possible hyperparameter values and identifying the configuration that gave them the best model performance. Normally, this is a super painful process as it requires the user to manually go through several iterations trying to find a certain configuration of hyperparameters, recording how the model performs, saying, hey, this is not good enough, let me go and tweak something, and go try it over and over and over again. This process can be really slow because imagine trying to iterate over every possible set of hyperparameter values when the space of hyperparameter values is really large. It can take forever to go through these, and not all hyperparameter values give you good results. So we can tell this is a lot of human effort, time, and compute resources that is wasted. Now, the solution that Azure Machine Learning offers is what we internally call hyperdrive, but externally, we simply call it hyperparameter tuning capability in Azure Machine Learning. So anybody who's training models using Azure Machine Learning can use hyperparameter tuning. Some of the main things that you would get by using hyperdrive is, one, it automates this entire exploration process. So a data science has to say, here's my set of possible values, and they define the search space by saying, here's a range of values or specifying a grid, apply some constraints, and start an experiment. And it automatically explores these hyperparameters for you. Another cool feature is efficient resource usage, or what we call early termination. Meaning the system automatically monitors model performance with the different hyperparameter values, and any configurations that were resulting in poor performance is terminated. This is cool because when it terminates that run for the user, it stops consuming that compute resource. So you won't be paying unnecessarily for compute for something that was not going to do well anyway. And instead, it uses the freed up compute resources to try other configurations. The next cool feature is that the user has control in terms of what they're trying to optimize for. So let's say you might want to maximize accuracy, or you want to minimize loss or whatever. Since you're bringing your own training script, you have control in terms of defining what is that primary metric you are optimizing for. Users can control budget in terms of how many configs should be explored in parallel. This can also be used across different learning domains, let it be deep learning or traditional learning, as you can take any training script and you're taking it one step further by automating the hyperparameter tuning. And you can also use any framework you like. And finally, we have some cool visualizations that let you see how these different configs performed against each other. Now that you have all the puzzle pieces from bringing in your data, doing the feature engineering step, training your model, either using automated ML from the UI, the SDK, or using hyperparameter tuning, you might wonder, how can we fit them together in your scenario? Well, I definitely recommend that you go ahead, try it for free. Visit our docs at ak.ms automated ML docs. Check out our additional sample notebook